Hello everybody and welcome to the penultimate video in our dungeon crawler series. So in the first video we wrote the add room method where a room becomes a vertex. We also wrote connect which is an undirected order between two rooms, and neighbors, which is the doors out of a room. Our self-test crosses phases 1, 2, and 3 are all green. Mapping shows the 10 rooms and their doors, including the entrance goblin skeleton cycle, and the sealed oubliette. Now, phases 4, 5, and 6 still fail. Two of those are going to be today's work. We're going to work on reachable, which is going to be breadth first search from a from, and can we get to a to? So it's a yes or no answer there. And then BFS order, which is the rooms in breadth first visit order, each once. Now both ride on the student, which is your floor 7Q, where we had dealt with enqueued, DQ, front, plus a standard unordered set, visited set, which is going to be the floor 11 hash set. This is really the composition payoff for the whole floor. We do not build a new container to cross the maze. We reach back for two that we already built. Now, three main beats here to carry the day. One, the queue comes back. So we put the floor 7 queue in play here. Breadth first search is just going to be in queue the start, then loop. We DQ, in queue its unvisited neighbors. First in, first out is why it comes out level by level. Number two, the visited set is what tames the cycle. We mark a room visited when we enqueue it before it enters the frontier, so then we can't enqueue a room twice and walk forever. And third, the shortest path for free. Because breadth first search reaches distance 1 rooms before it reaches distance 2 rooms, the level it first reaches a room is that room's shortest hop distance. The descend command rides a provided hops function, which is a breadth first search that counts distance. Okay, so let's go ahead and let's go to our hero queue header file here. Okay, so once again, this is kind of just looking at our interface from floor 7 here. Okay, so before we write a thing, let's look at what's already in our toolbox. So this is the queue we built on floor 7. NQ onto the back, DQ off the front, first in, first out. That's the entire engine of our breadth first search happening here. Now, the recipe is going to be we NQ the room we start at, then we loop. The front tells us which room is next. Our DQ takes it off. Then we look at its neighbors and NQ the ones we haven't seen. Notice in this idea here that there's a two-step. DQ doesn't return the room. We peek with front, then we DQ. So we ask and then we remove. The same split that the library's own standard queue makes. Because it's first in, first out, every room at distance 1 comes off the queue before any room at distance 2. The queue walks the map in rings, which is fanning outward. We don't build it, we just use it. So I just wanted us to make sure we took a second to kind of look at that. And back here to graph.header, let's go down and find our reachable stub here, starting at line 270. And notice here we take in a string here from, and we have 2. So let's go ahead here and get this going. So we're going to say if not has room from or not has room to, we will return false. Otherwise, I'm going to say Q of a standard string. We'll call this the frontier. And we'll say standard unordered set of type standard string. I'll say call this visited. And then we'll say frontier.enqueue the from. And I'll say visited.insert from. And then I'll say while not frontier.empty. So while we're not empty, I'm going to say if here is equivalent to 2, we'll return true. I'll say for const. I probably need to define here, though. We haven't defined here. So I'm going to say const standard string here, which is equal to frontier.front. And here I'll say for const standard string. Take a reference there called next. Go through the neighbors of here. Okay. So we'll say const string colon neighbors here. I'll say let's open up our next set of brackets here. I'll say if not visited dot count next. Then I will say visited.insert next, frontier.enqueued next. And then we should end up with 1, 2, 3. We then pop down right here before we step out of the brace for the function entirely. And I'll say return false, which means we drained the frontier without reaching R2. And then put a semicolon there. And I should have us good here. Okay, so we should be able to see this all kind of right here. Okay, so what's going on here? Well, this is our breadth first search, and it's the whole shape we'll reuse twice more. We have two tools. A queue, which is yours from floor 7, and a visited set, which is going to be from the standard library's unordered set. The hash set we used on floor 11. So to start with, we enqueue the front room and mark it visited. Then we loop while the queue isn't empty. Now, we read the front room and dequeue it. We peek, then remove the 2-step from the interface there. If it's the one we're looking for, we got there, we return true. Otherwise, we walk its neighbors, and for each one we haven't visited, we mark it visited and enqueue it. If the queue drains and we never hit the target, there's no path, then we return false. Now, in the most important 2 lines on this floor, I want you to watch the order. We mark a room visited the moment we enqueue it, and we check, have I visited this before we enqueue? Why does that matter so much? It's because of the loop. The entrance, goblin, and skeleton all open onto each other, which means it's a cycle. We walk into that with no memory, and we enqueue goblin, which enqueues skeleton, which enqueues the entrance, which enqueues goblin again, and there you go forever. The problem doesn't crash, it just hangs. That's the monster of this floor, the infinite loop happening on a cycle. The visited set is the cure. We check before we add, mark as we add, and then a room can never enter the queue twice. Okay. Now our second edit is going to be our bfsOrder edit here, which should be right below here. Starting on line 311 for myself here. Okay, so our bfsOrder, what we need to do here is to say standard vector. We need a standard vector of a string. And we'll call this order, and I'll say if not has room start, return order. Then I'll get me a queue going here of standard string. We'll call it frontier. We'll say standard unordered set. I need a string again. Call it visited. And we'll say frontier.enqueue the start. I'll say visited.insert the start. I'll say while not frontier.empty. I'll say const standard string here equals frontier.front. And then I'll say frontier.dequeue. And I'll say order.pushback here. So we record on visit, which is our dequeue. Okay. And I'll say for const standard string. Reference there next, colon neighbors here. Then we'll say if not visited dot count of next. I'll say visited dot insert next. And then I'll say frontier dot enqueued next. Bump out here before the last brace, we'll say return order. Okay. There it is right there. So, what are we doing here? Well, BFS order is really the same machinery happening as reachable. We have the same queue, same visited set, same loop, just with one change happening here. Instead of stopping at a target, we record every room as we take it off the queue into an output vector, and we return the whole walk. We enqueue the start, mark it, loop, and then we say front, dequeue, push the room onto the order, then enqueue its unvisited neighbors. Because the queue is first in, first out, the order comes out level by level. The start first, then everything one door away, then two doors away, and because of the visited set, every room just appears once, even though the map has a cycle. That exactly once level by level is the heart of breadth first search, and it's also why BFS gives the shortest path. The level you first reach a room at is the shortest distance. So let's go ahead and build this. Okay, and so I'm going to say self-test crossing now. Perfect. So you see here we get the okay on all three of those. Okay. So that's good. So our phases now, 4 and 5, are green. Okay. The great thing here is that phase 4, where we had the reachable, right, where we say, okay, can we find a path across this cycle? Let me check one thing here real quick. Okay, I think I found out the problem here. In our reachable, I have my frontier set, but you notice I never actually end up dequeuing it. So I should probably dequeue to start out with here. Let's see if that allows us to actually drain it appropriately. Okay, self-test crossing. Okay, that's more what I was expecting to see. Okay, so phases 4 and 5 are green here. Our reachable found a path across the cycle and correctly returned false for the sealed room. And notice it did not hang, which proves the visited set is working. Okay, I was hanging there a minute because I didn't drain my queue out. Phase 5, our BFS order came out in the pinned level order, every room exactly once. Only phase 6, which is depth first, which is going to be for the last video. Okay, so see here, BFS good. Fell right there on depth first search. And we got all of that okay. So we can also go through and say reach entrance to frost mall. You say, yep, a path runs from there. Say reach entrance to the oubliette, which we know is sealed off. I can't spell. Reach entrance oubliette. And there it says there is no path there. Perfect. So we see that works correctly there as well. We can visit the different paths. Now, let's also watch our level by level. I can say cross entrance BFS. It says breadth first from the entrance. We have the entrance, goblin, skeleton, wraith, necrothal, shadowhound, lich, stair, frostmaw. So 9 rooms reach level by level. So you can kind of read it as rings. We have the entrance first. That's a distance of 0. Then goblin and our skeleton there, right? That's everything that's 1 door away. Then we have our wraith and our necrothal, which is 2 doors. Then our shadow hound and our lich. Then we have the stairs, and then we have the frostmaw fanning outward level by level until the whole map is visited. 9 rooms, each exactly 1. Oubliette isn't on the list because we can't reach it. Now hold this order in your head because in the last video, we're going to cross the same map to depth first, and it will come out different. And keep this picture for the next command because the level a room shows up at is about to become a hop count. So check this out. Let's see here if we can say, well, can we descend entrance to lich? It says the shortest way from entrance to lich is 3 doors. I could say, well, how about entrance to entrance? 0 doors, perfect. Descend goblin to frostmaw. We see that's 4 doors. Okay, so this is the shortest way down. The question that the bard asked when we walked in. Descend entrance to list, 3 doors. Descend rides a provided helper called hops, which is a breadth first search that counts the level instead of just recording the order. You don't have to worry about riding it. It rides the same graph that we built. And it's free because BFS reaches a room at its shortest distance. Lich first shows up at level 3 in that walk, so 3 doors is the shortest way. And then we also see that we can do the entrance to entrance, which of course is 0 doors, and our goblin to frostmaw. Okay. So pretty awesome. We were able to figure out this shortest way, all handed to us via the mechanism of the queue. Okay, so at this point, the maze is crossable breadth first. You can ask whether a path exists, walk every reachable room level by level, and get the shortest way down indoors, all of it riding on the queue we built back in floor 7 and the hash set from floor 11, with the visited set there that keeps the cycle from trapping you. Now, in the last video, we're going to have the same crossing, but depth first over your stack, and then we close the whole descent. Hope this was helpful, and I will see you in the final video for the class here soon.